My name is Martin, and today I'd like to talk a little bit about visual testing. But most of you probably, when you think about visual testing, you think about visual testing as regression testing against the baseline. So you have a baseline for every screen in your app. And during the regression run, you check the current version against that. Actually, today I want to talk about some different or related approaches that use different tools, and you can pick and choose whatever makes most sense for your use case. So I found them quite useful to have in my test automation toolbox. So the three areas that we look into is template matching using OpenCV, layout testing using Galen framework, and OCR using Tesseract. So the first one is template matching. So the task is you have given an image and find it on the current screen. So go back here. Can you find Waldo on the left side? And that is something.
Martin, sorry to interrupt you. I think the
Yes.
slides are not showing up.
Okay, sorry about that.
We can see the slides in the non-presentation mode right now.
What about now?
Yeah, correct.
Okay, sorry about that. So yeah, the task is that given you have a template, you want to see whether it's present on your screen, and if so, where it is, and you want to be able to interact with it. Like, for example, click on that image. One tool that can help you with that is OpenCV. It's a C library for all sorts of image processing. There's a Java wrapper for it, so it's quite easy to integrate if you're using Java. It's also the one that's been used by Appium. So there are basically two approaches. One is the one that Appium chose for their mobile automation, where they run OpenCV on the same instance as the Appium server. And then you can talk to the Appium server and do template matching. The other approach would be to run OpenCV on the same machine where you run your test execution and do the template matching there. So how does it look like? So these are just very basic code samples. There's a link at the end of the presentation to more resources where it goes into a lot more detail. So I can just scratch the surface here, but just to give you an idea. So for Appium, it's just another locator strategy. So instead of finding an element by CSS, by ID, or by an XPath, you could also find an element by an image. And the way it works, you convert the image you want to find into a base64 encoded string, and then you pass that to the WebDriver. And there are a couple other APIs in Appium that also allow you to work with this approach. If you use OpenCV directly, there is a class called image processor and match template function where basically you pass in the same information. So very basic example in BDD format. Given I'm on the Google homepage, I want to check whether the logo is displayed correctly. That would be a simple example of performing template matching without the need to do a full visual regression testing of the entire screen, because I'm only concerned whether my logo is there. So there are going to be some resources at the end how exactly you can use that. The second topic I'd like to touch on is what I call layout testing. So here the task is that you want to verify the layout of a screen in your application. And you're not really concerned about pixel perfect comparison, but more about the position of elements in relative to each other. So for example, is the search button below the search box and things like that. And one tool that's very helpful for these kind of tasks is Galen. It's another Java-based test framework, and in my opinion, one of the most underrated test frameworks. So I haven't come across many people using it, but I find it very, very useful. And the way it works is basically you define all the elements on your screen that you want to interact or that you want to check. So again, a very simple example, search screen on Google. And you define these elements. It's not part of the code snippet here with an XPath, CSS ID, or any locator strategy. And then you can define how they should be positioned in relation with each other. So for example, the search field should be below the logo. The search button should be near the I'm feeling lucky button. The logo should be smaller than the search field. So just to give you an idea what kind of checks you can do. And it's very powerful. And the nice thing about it is it's all, it can all be modeled in a textual format. So you don't need any other tools for it. And the way I like to integrate it into a test framework is if you're using a page object pattern, I'll put it in an abstract base page and into a verify method. So every time there is a new screen as part of my test flow, I can call this method and it will verify the layout of that screen. So it's very very simple to integrate into the test. So here you see the test step. Well, this is using Cucumber. So it's just on the page object, the verify call, and that encapsulates away all the logic that Galen does to verify the layout of the screen. So again, a very powerful tool where you don't need a full-fledged visual regression testing tool just to do some layout testing. And finally, last one, I personally haven't come across a use case where I could use it in my current role to perform OCR, but I can think of some use cases where it can be useful to have that as part of the toolbox. When you have a text on your screen, but it might be rendered as a graphic, then you still want to verify that it's actually present. And there's a very powerful tool for that as well. It's called Tesseract. It's another library written in C that's been around for a long time. I think it's been developed by HP in the 80s and is currently an open source project at Google. So one example I did just to show that how powerful the OCR is on, again, Google search page. We want to verify that the Google logo actually prints out the word Google. And the way I would integrate it into a test framework is, again, having some sort of an OCR service where I can just call it a get text method and pass a locator. The WebDriver will get a screenshot of that element and then pass it to the OCR, to Tesseract, to get the text from that element. And then I can verify whether it matches what I'm expecting. So yeah, I just want to do a very quick demo just to more or less show to you guys that this is not just some slides, but there's actually code behind it that works. It's not the most interesting. It's a very simple Selenium test. I'll put the link to the code at the end of the presentation. So we're just opening Google and we run the 3 checks that I've been talking about before. And as you can see, it passes very quickly. So quite a simple and easy way to add a few additional checks to your tests. Yeah, as I mentioned, there's some additional resources. I'll also post the link in the Slack channel. There's a short Medium article where I put some more details if you want to play around with this and integrate some of it in your own projects. Also, if you have any questions, feel free to reach out to me. I'm happy to answer them or discuss in general how you guys are doing visual testing, what your experience is. I also put a link to a poll in the chat. Would be very curious to see your responses to that, because generally visual testing is something a lot of people I talk to, they tell me it's something we want to try and we know we probably should be doing, but it's further down on our roadmap. So it would be interesting to hear how many people are actually using it and what are people's experience with it. So yeah, that's it from my side. I think I was a little bit faster than 10 minutes. Yeah, hope something interesting for some of you. And yeah, feel free to reach out with any questions. Thank you.